So coming to the next question in practice problem, write the differential equations governing the behavior of the mechanical system shown. Also draw the analogous electrical circuit based on force current analogy. Okay, so solving this question, we'll start with the solution here. So step number 1, to draw the free body diagram. So for that, first we will consider mass m1, the forces acting on it. So coming to the first force, the input force is towards the downwards direction. Okay, and all other forces will act in the opposite direction. So first we will consider K1 and B. So K1, Y1, then due to B we have B dy1 by dt. Then we have, with respect to mass, that force is taken as m1 d square y1 by dt square. There is another force which is acting on this, that is with respect to K2. With respect to K2 we write it as y1 minus y2. This is the all the forces acting on mass m1. Now similarly on mass m2, okay, the displacement is towards downwards direction, so all other forces will be in the upwards direction. Okay, so we have, with respect to K2, it is K2 into y2, and with respect to mass of the body it is m2 d square y2 by dt square. These are the only two forces acting on mass m2. Now coming to the step number 2, it is to write the differential equations. Step number 2, write the differential equations. So first we will write for mass m1. We will have, based on the net forces, D'Alembert's principle, f of t is equal to m1 d square y1 by dt square plus b dy1 by dt plus k1 y1 plus k2 y1 minus y2. This is equation number 1. Coming to the next equation, we have m2 d square y2 by dt square plus k2 into y2. This will be equal to 0 because there is no input force acting on mass m2. Now this becomes my equation number 2. So this is the first part of the question, where we have written the differential equations governing the behavior of the mechanical system. The next part of this problem is to draw the electrical analogous circuit based on force current analogy. For that, I'll just redraw this here. Instead of redrawing, I've just taken, just copy pasted. Okay, so now we have this mechanical system. We need to draw the electrical circuit with respect to the force current analogy. Now there are two masses or two displacement. We have two displacements. Hence, we'll have two nodes. Coming to force current analogy, it will be parallel circuit. Okay, so I'll take this as node number 1. This is with respect to y1. And this I'll take it as node number 2. This is with respect to displacement y2. Now coming to the displacement y1, it is the displacement y1 is mainly because of the input force f of t, and the reaction forces k1, b and m1. So we'll start with the input force. The input force is f of t. In force current analogous, it is equal to current I. I'll take this as current I of t. Next we have mass. The mass is analogous to capacitance. Then we have damper coefficient, which is analogous to 1 by, I'll write this as C. Damper coefficient, it is 1 by R. Next we have friction, which is reciprocal of inductance, that is 1 by L. All this will be connected to a single node because it is with respect to one displacement. Now between displacement y1 and y2 we have k2, where k2 is the analogous to inductance. This is between the two displacements. I'll write this as L1. This is L2. So coming to displacement 2, we have only mass, which is analogous to capacitance. I'll take this as C1, this as C2, and all are connected to the ground. Are connected to the ground. It's not important to show ground always, but it's okay, fine. Okay, so this is the electrical analogous circuit. Thank you so much.